Hello, this is my EM1 assignment presentation. Question number one, we'll just go straight into it. Question number one. So here, basically, they want us to use this formula here, this formula, and apply it throughout this thing. So I will just demonstrate how I use this formula. I basically looked at whatever was corresponding to this, and then I locked these specific cells here. So I locked the B and C ones because I want to spread them out like this. So I don't want to go in and like individually input them. So I just put this and drag it down and all my values will come in perfectly. Okay. I must demonstrate to you how it changes depending on what numbers I put in for B and C. So if I change B and C to 2 and 1, it will change. Look, all the values have changed. Okay, let's go on to question number two. So I have two curves here. This is my first curve, which is y is equal to x squared, and this is my second curve, which is y is equal to x squared plus bx plus c. So I will demonstrate to you which one will change and which one will not. This one will not change. This one, the y is equal to x squared plus bx plus c will change. Confirm. So we had 2 and 1. Now we will move it up to 4 and 3. Or 4 and 6, actually. Yeah. Look, the graph shifts. There's a shift in the graph. There's a big change in the graph. However, this one remains unchanged. Okay, let's continue on. Let's go to question number 3. Display numeric and this numeric discriminant and numeric solutions to the equation. So here's my numeric discriminant. This is the formula I use for it. I use the discriminant formula, which is b squared minus 4ac. Okay, I just implemented that. I once again locked whatever cells I needed to because this formula is going to be used for both of these formulae. So here my discriminant is 8 if I change my numbers to 2 and 1. My discriminant changes to 1. My discriminant will change to 1, and here will become 0. Yeah. My numerical discriminant changes to 0. Okay, now let's continue on with question number 4. Given the function, so I wrote my conclusion statement as you can see here. There's a slight error there, but it's okay. Basically, how this graph shifts is that when the value of b here, okay, when the value of b here is increased without increasing c, a change will happen. Okay. The midpoint of the graph, it will shift to the left side of the x-axis, and it will shift downwards on the y-axis. The opposite can be seen when the value of b is decreased. Okay, now the y is equal to x squared plus bx plus c graph will always shift from the y is equal to x squared graph, as the y is equal to x squared graph does not ever change as its value is consistent. The increase of the value of c will result in the graph of y is equal to x squared plus bx plus c shifting upwards on the y-axis, and the decrease of c results in the graph being shifted downwards on the y-axis. I don't think I must demonstrate this to you, but I'll do the same. I'll just do it. She'll leave it. It's not written here. I need to verbally explain it. Okay, now question number 5. Okay, so these is the discriminant rules as we know. The solution, so you know how the first rule states that, the second rule here states that if the value is equal to 0, there will be one real solution, one real solution. And if I change the value, so if I just put 7 here or 8 here, 60, look, there's two real solutions. And if I put a negative number, I don't know, like 5 and 3, maybe, it will give me a different kind of solution. Look, it's positive once again, sorry. This has to be bigger than that. Look, it will give me a negative number. There's no real solutions. So that's it. That's my project. Thank you very much for watching.